Welcome to the lecture series. In this lecture series, we are discussing about the unsupervised learning techniques. And in the previous sections, we have discussed about K-means algorithms and DB scan. Now we are going into the support vector missions. So support vector missions, it's an algorithm that finds the optimal hyperplane to separate the data points into classes. So in the K-means clustering and algorithm, we use as a spherical grouping. Here we have the hyperplane. So here we have the few parameters which we have to note it down. First one is maximum margin. It is the widest possible separation between the classes, and support vectors, and this is the critical data points that defines the distinction boundary. And kernel trick here comes for the higher dimension. When we are going for the nonlinear data sets, we can convert this dimension 2D to 3D dimensions, convert it into higher dimensions, and for that conversion we use it for the kernel trick. And for the applications, we can do it for classification, regression, and outlier detections. And coming to the understanding of SVM uses, and find in the real world we can use for optimal solutions, mainly for classification, regressions, and medical diagnosis like disease classifications and grouping of patient data, face recognition, robotics, bioinformatics, and text classifications like spam or any other calls, and financial like credit score and fraud detections, etc. These are the basic real world applications. From here we have to think how it can be evolved and how it can be developed and how it can be used. Coming to the defining stage, so SVM, it defines the optimization problem that solves to find the optimal hyperplane, right? So objective is to maximize the margin between the classes so that the decision boundary can be made optimal. So decision bound is nothing but the hyperplane which separates the data points, and constraints is to ensure correct classification of training data. And dual problem, Langerian formation with the kernel classification, which goes for the higher dimensionalities. Next, coming to the ideate, so here we can explore SVM variants and kernel functions. So coming to the types of SVM, we have two types, that is nothing but the linear SVM and nonlinear SVM. So linear, direct hyperplane separation for the linear separable data, whereas coming to the nonlinear, it uses the kernel function to map the data to the higher dimensions, as we discussed earlier. And coming to the margin, also we have two types of margin. One is the hard margin and the soft margin. Strict separation with no calculations allowed. It comes for the hard margin. Whereas soft margin, it allows some misclassifications for better generalizations. So for example, in this image you can see here it has some misclassifications, right? So it can go for the soft margins, and here you can see there is no misclassifications allowed. It strictly follows that point, so that comes under the hard margin. And coming to the linear nonlinear, also here you can see there comes a linear straight hyperplane, and here we have the non-linear polynomial type, so it can be adjusted according to the separation type. And implementation step is, first we go for the data collection and pre-processing. So pre-processing includes the data collection, data handling, and normalization the features. And next comes under the feature selection and engineering. It selects the relevant features, creates the features if needed. And come here you can see a problem like we are importing the SVM. So model SVM, that is we are importing the kernel function here, and we are giving the type of data also. And model selection and training is nothing but it uses the kernel function, tune the hyperparameters, and train the models. And model evaluation is access the performance using the cross validation and matrices. So here you can see the flowchart. We should gather clean, that is cleaning is nothing but handling the missing values and assigning the unlabeled data and finding out the features. And here next comes the choosing of right algorithm, and we are building that algorithm into a model, and next we are transforming and going for the validation. And coming to the testing part, validation part, as we have to assess the model's performance using the metrics and validation techniques. Here we are looking for the precision, and we will recall, and we go for F1 score, which is the harmonic mean of precision and recall. And next comes under the accuracy, that is overall correctness of the model. So cross validation we can do like k-fold CV helps access the model generalization ability and prevent the overfitting. So this is the overmap, mind map of the concepts. Yes, we have the main objective of maximum margin. We're looking for the optimization, dual problems, and decision boundaries. We have two types, linear, non-linear, and two types of margin, hard and soft margin. And coming to the kernel function, it uses linear, polynomial, radial basis, and sigmoid. And evaluation metrics, we have looking for the precision, recall, F1 score, accuracy, and k-fold cross validations. So in the next lecture series, we will discuss about the supervised learning techniques and also the algorithms under it. Thank you.